Hello, my name is Rich Howard, owner of Architectural Builders Supply. In this video is to discuss how to determine the proper length of a mortise cylinder depending on your application. And what I mean by that is when you're working with a mortise cylinder, you might be inheriting the size that you need to use, meaning the size of the mortise cylinder or its length is, it's 1.1 inch. That's what comes with the mortise lock. It's going to come with a trim ring or a collar for a typical 1.75 inch thick door. You don't need to worry about the length because the way that it's packaged standard from the factory will work just fine for your requirements. Okay. There are many instances when that's not the case, when you are not inheriting the size. And you do need to determine the length of the cylinder. Sometimes you need to just determine the thickness of the trim collar or the cylinder ring or the guard ring, whatever the proper term is that you want to use. This happens to be a high security cylinder, mortise cylinder by Multi-Lock. I just had it on my desk. So the specific length of this cylinder, the thickness of the trim ring, that all conspires to give you a proper installation. So you might not need to think about it at all. You might be well served to think about it. Or you might have to absolutely figure out what you need so you can order the right length cylinder. If you have to think about it at all, there's no reason to watch this video. If you do need to give it some consideration, well, then this video may help. And if you've got to figure it out, let's figure it out right now. I often will be involved in a project where the client requires a custom length cylinder because the requirement for a custom length cylinder is a byproduct of the application. So here's the door application, and by the way, the cylinder is going to have to be custom. And generally, when you have a custom length cylinder, there may be other custom pieces that you need, custom length or odd size items such as thumb turns or spindles or screws or lip length on a strike plate, depending on the application. So generally where I see this is when I have the most common is when you have a door that is either in swing or out swing. It's a mortise lock. And the client is taking an otherwise standard thickness door of 1.75 inch, and they're applying, let's say, a 1 inch thick panel to the push side of the door, and the door is either left hand or right hand. So that's going to be that would be on the secure side of the door, or the secured side of the door, I should say. The side that's locked, the side with the key, is the secured side of the door. Okay, so you're not going to be able to enter. So you've got an otherwise 1.75 inch thick standard door that they've added 1 inch to this side. Well, just common logic would tell you, well, what's the standard size of the cylinder with the lock? Add 1 inch to it. That certainly works. There's no doubt. In that sort of application, you're going to need, for that mortise lock, likely certainly a longer spindle, longer screws possibly, or mounting posts. You won't need a custom thumb turn if it's a function that has a thumb turn, or the spindle on the inside, or the lip length, because it's an in-swing. If you were doing that same application and it was out-swing, you've got a left-hand reverse or a right-hand reverse, where it's an 1.75 inch thick door with a 1 inch panel applied on the secured side. You're going to need that longer cylinder. You're going to need an extended lip strike, and then everything else I said, the longer spindle, the longer mounting posts or screws, but you'd still use a standard thumb turn. That's an easy scenario to figure out. If you're adding 1 inch, well, add 1 inch to your cylinder. Do you need to add 1 inch? No, you could probably live with a little longer or a little shorter, and that variable is going to be taken up by the cylinder collar or the trim ring that you're going to end up using. Okay. Now, let's take a look at the application where you've got to absolutely figure it out. Let's do that right now. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So in these applications where I've got to figure out the length of the cylinder, I have come up with a formula, and so far it works. It may or may not be the final best derivative of the formula, but here it is. The formula that I've come up with, and I'm sure it is likely somewhere else in some industry catalog, but it's dt minus G plus C1 plus C2. So dt is door thickness. So you take your door thickness, and the next part of the formula is minus G. The minus G is subtracting the gap that you would require between two cylinders. So this is a Adams Wright 4510 Mortise, Adams Wright 4510 latch. So when I thread that cylinder in there, I am subtracting the amount of, I'm going to subtract the amount of room that I need between the two cylinders. Okay? Aha. Okay. Yes. Okay. So the bottom line is I was getting hung up, and I can see it's because the set screw is here. I need to draw that out. I don't have a small screwdriver within arm's reach. The bottom line is, when I thread that all the way in, I want to leave, in this scenario, I'm going to leave 1/8 of an inch between the two cylinders. If I installed one over on this side, I want to leave 1/8 of an inch. That's what I'm going to plan on. But you can't consider 1/8 of an inch to be the size or the gap that you need to leave, because you may have like an 8710 Adams Wright where you are going to need more, like a 1/4 inch gap between here. The bottom line is, before you determine dt minus G for gap, what is the gap? What does it have to be? I know that this is a 4510. I can leave 1/8 of an inch. I could leave a 1/4 inch. I could probably even leave 3/8. So determining the formula, determining the right length of the cylinder, is also going to be based on knowing, knowing a little bit about your lock. Okay, I've got the wrong cam on here, so it's not going to work. But where I've got that threaded in, if it was the proper cam, it would engage the retractor so I could pull the latch back. So you've got to understand what gap you need. That will require knowledge of the lock. And unfortunately, you do need to know that information in order to comfortably determine the length of the cylinder. The rest of the formula is, or starting from scratch, dt minus G plus C1 plus C2. So C1 is the first collar that you're going to use. You'll add that dimension. Okay? Then you'll add the dimension of the other collar that you're going to use. So door thickness, 1 3/4 minus 1/8 plus your collar. I happen to know that this is, that this is about 1/8 of an inch, because it's the shoulder here. Okay? So plus C1 plus C2 plus 1/8 plus 1/8. So 1 3/4 minus 1/8 is 1 5/8, plus 1/8 is 1 3/4, plus 1/8 is 1 7/8 divided by 2. That's 15/16. Okay. The right size cylinder you need is 15/16. Now you're going to say to yourself, well, I'm doing interchangeable core. Well, you need 15/16, assuming you're using an 1/8 inch collar. You're then going to have to figure out, how close can I get to 15/16? Can I get, they do make 15/16 mortise cylinders. You won't get a multi-lock high security cylinder in 15/16. You won't get interchangeable core mortise housings, small format or large format, in 15/16. So then what you'll end up doing is determining what cylinder you will use, say 1 1/8. Then you're going to take that dimension, 1 1/8, subtract from it the 15/16. You have 3/16. You're going to add that to your C1 dimension. So now you're going to need a collar that's 15/16. 3/16 plus 1/8, 15/16. And that's how you end up doing that. So door thickness minus gap plus C1 plus C2 will give you the theoretical size. You take that theoretical size and then you fight to find out what size you're going to use, or what size the lock platform is available in, or what you're going to end up being able to achieve, meaning what can you get your hands on. I need a 15/16, but this cylinder I can only get 1 1/4. Okay, well, you're going to add 5/16. 1 1/4 minus 15/16 is 5/16, plus the 1/8 of an inch that we've already calculated. So you'll need a collar to make that up. Those longer cylinders, 1 1/4, inch and 3/8, that will be an application where you can't get shorter cylinders, okay? So be mindful of that. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Now, an application of where you're going to end up needing to think even deeper about this is going to be where you have an unusual door thickness that may or may not be combined with the placement of the lock in an unusual application. So it's very common for me to be in a position where someone needs a 3-inch long cylinder, except that they need a 3-inch cylinder on one side and then a 1-inch cylinder on the other side because the lock is not centered in the thickness of the door. So what I end up doing in that scenario is I run the formula twice. I basically determine what the length of the first cylinder is by taking the thickness of the door, determining where the lock is located in the thickness. So let's say if it's this is a real example, 4 and 15/16 was the last one that I did. So basically a 5-inch thick door. He was placing the lock 3 inches from the one side of the opening. So I'm going to run my formula based on that being a 6-inch thick door. So I'll take 6-inch minus the 1/8 inch gap, plus collar 1 plus collar 2, divide that by 2, and then I get the length of the one cylinder. Then, over here, I need to figure out, I've got a 5-inch door, I'm 3 inches in, that means I'm 2 inch over to the center line. Then I do a 4-inch thick door, okay, minus the 1/8 inch plus C1 plus C2 divided by 2, and then I get the other dimension of that cylinder. Let's switch to the screen view and let's take a look at I suppose just graphically writing this out. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So I certainly hope that the calculation of cylinder length was of some benefit, and I certainly hope the math was correct. If you have any way to improve on this formula, this idea, and I had started out initially just with the dt minus G+C1+C2. It is divided by 2 because you're coming up with each cylinder is what you're doing. So you have to divide all that by 2. So if you can improve on it, please share your knowledge and your experience with us. I would love to hear back from you in any way regarding a constructive way to add to the conversation. Thank you very much. My name is Rich Howard, owner of Architectural Builder's Supply. Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.